to give you a quick review of the different questions and uh, different solution and different questions related to the exam and revisions of these three labs. So let me share my screen first. So, okay. Then, so here is our lab reports. So we're going to solve it, these lab reports, and try to figure it out what kind of things we wanted to discuss. So these three lab reports you already submit in your class. So let's discuss it. For example, the lab report one is based on errors in data analysis. So the first question is significant figures, which you already learned in your General Physics 1 course and in this lab course as well. So significant figures are the numbers or all accurately measurable number, and first doubtful digit is your significant figure in your measurement. So the rules for the significant figures are that the zero in between the numbers is always significant. So this has 3. So for example, 2.30 has also 3. So after the decimal point, like this, or 2.00 has also 3. So these two are significant as well. But if we write like 0.002, so this has only one significant figure because these are placeholder and not significant. So in that case, for example, this number has 3 significant figures, this number has 2 and 5, and similarly this has 3, and this number has 5 and 6, 5, yeah, 5 numbers. So you can write it like, and you can write it like in terms of the scientific notation as well. So now, so scientific notation, you can write it like, for the 2 significant figures, for this you can write it as 2.5, 10 to the 1, 2, 3, 4, 10 to the 4. So you can write it like this. And these are the 2 significant figures. Okay, so now we can add and subtract significant figures like this. So for the rules for the addition and subtraction is the same. So you need to select a number that has fewest numbers, like in that case, in this example. So in this example has 3 numbers after decimal point, and this number has only one decimal point after 1 decimal point. So we need to select that number as a reference, and our answer should be expressed in terms of this number significant figures. So let's solve it. For example, this 68.325 minus 18.6. So the answer is 49.725. Okay, 49.725. So this number has 3 significant figures. So we can express as 49.7. Okay, and the same goes for the addition. Now, in terms of the division and multiplication, for example, in division, the rule is the same. You need to select a number that has fewest significant figures. Fewest. For example, this number has 3 significant figures and this number has 4 significant figures. So you need to select 3 as a reference and you need to express the answer in terms of the fewest number. So for example, 22.0 divided by 12.24, you will get 1.7973. So this is your number. So you need to express in terms of 3 significant figures. So you can write it either as 1.79, or you can approximate this number into 0 and it will become 8, and then also. Okay, so this is multiplication example, and this is for example, so this has two significant figures and this has four significant figures. So when we multiply 4.0 multiply by 350.9, so you will get 1403.6. So you need to express in terms of the two significant figures, so you can write it as like 1400, because these two are not significant. Okay, great. So now we get the value. Okay, then okay, so in an experiment you measure the acceleration due to gravity. So it's a kind of an important question, so you can find it in your exam. It could be a question. So an experiment to measure the acceleration due to gravity, two values 10.6 and 10 points are obtained. The theoretical value is 9.8. Find the percentage error. So what is so how could we find the percentage error? So you just like x minus y divided by x plus y divided by 2 multiplied by 100. So x, so you have, and you take this as positive values, mod values. So you will get a 10.10 minus 9.60. Okay, this is 0.5 divided by 10.10 plus 960, 9.60. Okay, not divided by 2 divided by 2 and multiplied with 100. So you will get 5.07% of error. Okay, so the percentage difference of the measurement is this, the percentage error of each measurement. So percentage error in each measurement, like this is, for example, if we consider this value, so for example, this value is 9.60 minus 9.80, your theoretical value, divided by 9.80, your theoretical value, multiply by 100%. So what you will do in E minus T divided by T, multiply by 100. So let me figure it out. 9.60 minus 9.80 divided by 9.80 multiplied by 100. So the percentage uncertainty is 0.04, 2.04%. Okay, so you need to calculate the percentage difference of the measurement and the percentage of the error. So error can be calculated, for example, 5.70 plus or minus 0.1 is given, and you need to calculate the percentage error or percentage uncertainty, which is 0.1 divided by 5.7 multiplied by 100. Okay, this is how you get. Now draw the graph. So this is a straight line. So the plot for this is a straight line like this. So this is your x and this is your y, and it could be like this. So it could be like like this. So this is your C. So Y, so X, Y. Now you can plot like this. So this is a, so the plot of this would be like this. Okay, so in this case, so y equals to mx plus c. So your slope is 7.4 and c is 3. And you can plot it like this. Okay. So now if you get below, so the uncertainty in time, you add these values and summed it up, okay, and then divided by 4, so you will get the average value of the time. So the average value of the time, what I suppose from this 6.27 plus 6.28 plus 6.30 plus 6.29 divided by 4. So this is your value time, which is average value 6.285. Okay. And the uncertainty, the average duration is 0.01. Okay. So if you see the difference between them is 0.1, 0.01. Okay. Then the average velocity is the same as the case. You will divide this and you will write the number as well. And then because they are multiplying, so for example, you need to find the position uncertainty. So let's suppose this number has, I suppose that this number is, I suppose that this is 11.29 plus or minus 0.02. So the difference is like 0.02. So how to find the uncertainty? So first you will find the value, which is 6.285 multiplied by 11.29, which is 70.96 meters. So now do find the uncertainty. So you always find the uncertainty when you are multiplying. For example, if two numbers are like multiplying, a multiplied by b, so you add the uncertainty of a, delta v over v, delta a over a, delta a over a plus delta b over b. Okay, so what you will get c, so c would be delta c over c. So this is, in this case you have d. So it's just looking like delta d over d equals to delta v over v plus delta t over t. So you have delta v this, v this, delta t this, t this, and you just substitute the values and you have the d as well. So you can calculate the value. Similarly, for the case if the numbers are dividing a over b, so you can write, you can add the uncertainty as well. And if the number is like a plus b, so you can add the percentage uncertainty of percentage uncertainty a and percentage uncertainty b. You can also add these things. Okay, so now for example, uh, now if you wanted to calculate what will be the percentage if the situation is like this, c equals to a squared times b. So you multiply the percentage uncertainty and then add, or you can delta A plus delta A, 2 times addition because it's squared. And we will do this example as well. Okay, so this is your second experiment. And so to calculate the fine measurement using the 1-year caliper and screw gauge, so we wanted to calculate the density of the cylinder and density of the sphere. Okay, so for example, when we do the experiment, we get the values. And for example, we have value from the 1-year caliper is 4, and you have the difference, average difference 368. And from the micrometer, you read the reading 4, and it's 0 0.12, 112. Okay, 1. So what is your mean so mean height of the cylinder? So when you measure with the 1-year caliper, you put it in the 1-year caliper, and in between that your height will give you like 3.9, I think 38.9. We can write as millimeter. And then we can write the uncertainty. Uncertainty is delta H. So this is, we can write at 0 0.04. So this is 0. And the diameter, which is 9.50, 0 0.01. And we can, this is delta D, this is your D, this is delta H, this is your H. Now the mass, when we do it on the mass weigh machine, so we get like 23.3 gram. And your uncertainty in measurement, we can write it like 0 0.01 or 0 0.02. So we can find, because 1-year caliper has a least count 0.1 centimeter, well, screw gauge has a least count 0.01 centimeter or 0.01 millimeter or 0.01 millimeter. This is in centimeter and this is in millimeter, and you can find the least count divided by 2, so you get the uncertainty. So now what is the mean density? Mean density is mass per unit volume. So volume of a cylinder, so we can write it, volume of a cylinder, we can write it as pi r square h. Okay, and r is related to the diameter, d divided by 2. Okay, so d divided by 2, so we can write it as 4 pi r square h. Okay, so your volume is 4 pi r square we can replace as d square divided by 4 h. Okay, or this, I think this is not the 4, so this is not 4, it's pi square h. Then v is pi d square h over 4. So these are constants. This is not included in your uncertainty, but it included in the calculations. So our calculations will become mass divided by the volume. The volume is pi d square h divided by 4, and this will go for up. So you will get 4m, and when you substitute the values, you will get the density. Now the uncertainty in your density. So if you see the formula for the density is its mass per unit volume, and volume is d square h. So in the previous case, we were calculating the uncertainty using this formula. So how do we write the uncertainty in delta rho divided by the rho? So rho will coming from here. Then m. So delta m over m plus d squared 2 times delta d divided by d plus delta h divided by h. Okay, so this is how you get the uncertainty in your density. Or rigorously, you can take a square root of it and you can find the exact uncertainty. And this method is also applicable. So if you're calculating the uncertainty, so delta rho, which is your uncertainty over here, will come from delta m over m plus 2 delta d over d plus delta h over h. So this is how you can calculate the uncertainty. Okay, now we can calculate, for example, the reading for the density of the sphere. Let's suppose I have, yeah, so what I have over here is 5.86 millimeter, and we can find the least count dividing by 2, so 0.01 divided by 2, or 0.001, I think. Yeah, so you can write it, so you can calculate the mass and the least count as well. So what is the density? Density is also mass per unit volume, and the volume of a sphere is nothing but 4 3 4 over 3 4 over 3 4 over 3 pi r cube. Okay, so you can calculate 4 over 3 pi. So r is d cube divided by 8, because r is d divided by 2. So you will get pi d cube divided by 6. Okay, so when you substitute the value of from d over here and put the value, you will get the volume. And when you divide this volume, mass divided by the volume, so you will get mass divided by pi d cube divided by 6. So this is how you calculate density. Now the case for the uncertainty is uncertainty. So delta rho divided by rho is equals to, so if you see this, this is mass and this is d cube. So 3 times delta d divided by d plus delta m divided by m. Okay, so this is how you calculate the uncertainty. So your delta m equals, delta rho is rho 3 into delta d over d plus delta m over m. So you have delta m, you have m, you have delta d, which is coming from here, and you have delta d, you have d. So you can substitute the value and you will get the uncertainty in your measurement. Okay, so you can see the experiment over there as well. Now we are calculating the force table, which is the third experiment we have. So for example, we calculate the resultant and direction. So we did the experiment. So holder is 0.05 kilogram. I'm not sure, but it's 0.05 kilogram. So we did this experiment and we can calculate the resultant force, which is like this force and this force, F1 and F2, and there is a resultant force like this in the force table. And we see that this resultant force lies between the F1 and F2, which is your resultant force. Okay, so if the force is given, so for example, any force is given, you can calculate its component. So your x component is nothing but the f cosine theta, y component is f sine theta, and you can calculate the force, which is nothing but fx squared plus fy squared, and theta is nothing but tangent of inverse fy over fx. So these, when you calculate these values, these are our theory value, and when you do the experiment over here, you will get the resultant mass, resultant force, the resultant direction. The same is here. So you will get the experimental value, and so when you put over here experimental value, theory value divided by theory value multiplied by 100, so you will get the percentage value of error. Okay, so you need to calculate the percentage error in force and in the direction. So here we calculate direction. This is force from theory. Okay, so these are two questions, which is, for example, the two forces are applied of the force at angle 95 degree and the other is 170 degree. So the regardless of the magnitude of the forces, the equilibrium will be, for example, if we draw the coordinate system, so 95 in the second quadrant and 170 is also in the second quadrant. So the third force has to be lie over here, which is the fourth quadrant. So the two forces of the magnitude, this and this, is applied on the force table, which best describe the limitation on R, the resultant. So if we sum these two values, it will become 13, and if we minus these two values, it will become 5. So the range of the force is, it should be less than 13 and greater than 5. Okay, and this you can easily solve. So f cos theta. So you have theta, you just substitute the value into it, you will get the components. So this is just a brief review. So the main concept is uncertainty. I will explain it over here as well. So if you want to calculate the uncertainty in numbers, when the numbers are multiplying, for example, C is A cross B, so you can add delta C over C, which is delta A over A, uncertainty in A, plus delta B over B. So you add uncertainties like this. Okay, and if you have given the percentage uncertainty, just add the percentage uncertainty. Percentage uncertainty of A, percentage uncertainty of B. Okay, and if the numbers are adding, so delta C over C, delta A over A plus delta B over B. And the same case for the division and the same case for the subtraction. So in case of the volume or density is mass per unit volume. And if the volume is given of the sphere, which is m is 4 over 3 pi r cube, so these are constant. This is not included in the uncertainty calculation. So delta rho over rho is delta m over m plus 3 times delta r over r. So whatever you calculate. So these are the rules that will be helpful to you. So you can find the values like this. So hopefully this will cover all your syllabus for the quiz. So I'll see you in the quiz and hopefully you do it well. So see you in the class and best wishes.